Welcome to this explainer. Today we're diving straight into transforming raw, noisy logs into highly actionable metrics using Grafana Loki's advanced LogQL parsing. If you've ever felt totally overwhelmed by endless streams of unstructured text, well, you're in exactly the right place. We're going to take that chaos and turn it into absolute clarity. Let's get into it. Here's our roadmap for today. We're going to start by taming raw log chaos. Look at regex and capture groups, check out the simpler pattern parser, do some reshaping with label format, build custom line formats, and finally wrap up with a real-world P95 latency scenario.
All right, part one, taming raw logs chaos using the schema at query philosophy.
Look, in modern distributed systems, trying to maintain rigid log schemas, it's an absolute operational nightmare. And that's exactly why Grafana Loki defers the structure to query time. Just imagine you're sitting there, in the dark theme of the Grafana Explore tab, staring at a raw, chaotic string of text. All that high cardinality data is just jammed into a single string. It makes it incredibly difficult to figure out what's going on when the pressure is really on during an incident. This is exactly what we're trying to fix. Our ultimate goal here is bridging that massive gap between just having visibility and actually understanding your data. By converting all that raw noise into perfectly extracted, clean key-value pairs, we unlock the ability to dynamically query and aggregate everything. It's a total game changer. Moving on to Section 2, Regex parsing and capture groups for precision field extraction. So when your logs absolutely refuse to fit a standard format, Loki's regex parser becomes your absolute best weapon. It uses Go RE2 syntax, which means you get really high performance extraction. But the absolutely crucial part here is the named capture group. By just defining a name right inside your regex, you're literally taking an arbitrary piece of text and elevating it into a first-class temporary label. And once it's a label, you can immediately filter or group by it. Okay, let's watch how we methodically build this pipeline step by step. First up, we grab our application logs using a stream selector. Second, we throw in a simple line filter, basically a distributed grep, to instantly narrow down our data to only the lines containing the word error. Third, we drop in our regex parser. Now, quick tip, filtering before parsing is a massive performance booster. You definitely want to do that. Once we run this whole pipeline, boom, that extracted IP label just magically appears ready for us to analyze. Which brings us to Section 3, the simpler pattern parser, which is a fantastic high-performance alternative. Now, if you're dealing with standardized log formats, Loki gives us a way more intuitive option than regular expressions. When you compare the two, the difference is night and day, right? The pattern parser gives you a beautifully clean template. I mean, let's be real, crafting that regex might take you 20 minutes of trial and error, but the pattern equivalent? You're literally just typing out the structural literals using angle brackets. It's so much easier. Here's the breakdown of how it works. You use angled brackets around a name to explicitly capture a field, and you use an underscore inside those brackets as a wildcard. That just skips over any text you don't actually care about. But here is the real hidden superpower, performance. Because it just tokenizes the log line based on fixed literals, like spaces or dashes, the pattern parser actually saves a ton of CPU cycles. If a line doesn't match your literal template, it just stops processing instantly. So it's incredibly fast and it's super readable. A total win-win. All right, Section 4, reshaping with label format and how we modify those extracted labels. So once we actually have our labels extracted, we pretty much always need a way to refine them, right? That's where the label underscore format expression comes in. It lets us effortlessly rename, modify, or even combine our brand new labels right there in the pipeline. This is an absolute lifesaver when you need to resolve conflicting field names or merge a few categories together before you run an aggregation. Moving right along to Section 5, crafting custom line formats to build readable outputs. Okay, so now our data is logically structured, which is great. But during a frantic incident response, human readability is everything. We don't want to squint at massive JSON blobs. By using the line underscore format expression, we can just inject our extracted labels right into a Go text template using those double curly braces. It strips away all the background noise and presents only the critical data you actually need to see. And the aesthetic power of doing this is just undeniable. What used to be this massive, clunky, multi-line JSON object is now a perfectly condensed, beautiful little summary. You instantly get the method, the path, the status codes, and the duration all in one quick glance. It's so clean. Finally, Section 6, A real-world scenario taking P95 latency from raw text to a metric dashboard. Let's look at how we tackle a real support scenario over in Grafana Play. We need to extract response times to build a full metric query pipeline. First, we use the JSON parser to grab the fields we care about. Next, we use the unwrap function. Now, this part is absolutely vital. Unwrapping tells Loki, hey, stop giving me log lines and instead extract this specific latency value as a raw numeric metric. And then finally, we apply our PromQL style aggregation over a 5-minute rolling window using quantile_over time. But hold on, there is a catch here. What if your logs print that latency out as a human-readable string, like 300 ms or 1.5 ses? Well, that's exactly where conversion functions come into play. This conversion is an essential intermediate step. It ensures that our quantize function can actually perform mathematical operations on something that, until a second ago, was literally just text. We just wrap our label in duration_seconds, and Loki completely handles the math for us. And the final result of all this work is this beautiful, highly actionable graph. Think about it. We started with thousands of lines of chaotic, noisy JSON text. And by using LogQL parsers, unwrapping those values, and applying aggregations, we've successfully distilled all that unstructured chaos into a precise, proactive health monitor for our API endpoints. Which really brings us to one crucial final question for you. What critical unknown unknowns are hiding in your unstructured log data right now? I highly encourage you to open up your own Grafana instance and just start experimenting with these advanced parsing tools. Whether you need the surgical precision of Regex or you want the blazing speed of the pattern parser, go discover exactly what your logs are trying to tell you. Thanks for hanging out with me for this explainer, and happy querying.